Okay, so to review how to do these quadratic equations, let's just review what we're actually looking for. When we have these quadratic equations, they're parabolas. So it could be a parabola, let's say, going like this, or it could be a parabola, let's say, going upside down. So let's say something like this. When they ask us to solve, or another word is find the zeros, they may also say find the x-intercepts. When they use any of these terms, what we're actually trying to do with these equations is to find where the graph is actually crossing the x-axis. So that's what we're finding. So when we find things like when we get x equals 3 or x equals 4 or even x equals, let's say, -6, we're finding what these points are where the graph actually crosses the x-axis. So whether they say solve, zeros, or solutions, or x-intercepts, we're just trying to find where that parabola is crossing the x-axis. So that was just to kind of clarify what we're doing here. Now, when we're solving, we have a bunch of different methods. We're really just 3 different methods that we can use to solve. So the first method that we'll go over is factoring, the factor method. So you guys did a really extensive unit on factoring. So when we do the factor method, we're just trying to factor to get it in terms of 2 parentheses. And we're gonna take advantage of something called the zero product property. That's gonna be really important to help us solve. So the zero product property is something that's really important when we're doing this factoring. So once we factor and we get the 2 sets of parentheses, we're going to use this zero product property, which means we're just going to set these equal to 0 and we'll kind of go from there. But we're going to do several examples. So let's say that we have an equation that is x squared minus 4x minus 12 equals 0. So one thing to keep in mind when you get these equations, if you're given an equation and it's not equal to 0, we have to make it equal 0. So let's say they gave you this equation, but instead it was x squared minus 4x equals 12. Well, this is fine. What we would need to do first is we would need to subtract the 12 from both sides because we have to have the equation equal to 0 before we can technically factor. Same thing is true if we're using the quadratic equation. We have to have these guys equal to 0. Okay, so if we're starting here and we're factoring, we want to figure out things that multiply to -12 that somehow add or subtract to get us -4. Okay, so I'm going to list the factors of -12. So we are factors of 12. We could do 12 and 1, 4 and 3, 2 and 6. And we want those factors, the set of them, to add or subtract to -4. So it looks like these are going to be the ones, 6 and 2. We'll have to do a -6 and a +2. So then what I'm going to do is we'll do x plus 2, x minus 6. So that's how we would factor it. But if the directions are to solve, we have to set this equal to 0, and we're going to use that zero product property what we talked about. And so what we'll do then is we'll take each of these parentheses and we'll set them equal to 0. So x plus 2 equals 0 and x minus 6 equals 0. And then from there, we'll just do a few algebraic steps. We'll just subtract 2. So we get x equals -2. And we will add 6 here to both sides. So we get x equals 6. Okay? So these would be our final answers, -2 and 6. So what does that actually mean? We get -2 and we get 6. What that means is we had some type of parabola, let's say like this, and it is crossing at -2 and it's crossing here at 6. So that's what those mean. That would be one zero or one solution, and that would be the other. So -2 and 6 is kind of what those numbers mean. So that's the factoring method. Let's do another factoring using one that's a little more complicated. We'll do 2 more actually. So let's say we have 4x squared plus 12x plus 8. And again, we have to always make sure it's equal to 0 before we can technically factor it. In this case, it's already equal to 0. If you can, you want to divide by anything that these numbers have in common just to make the numbers a little bit smaller. In the example we did before, we did not have a number in front of the x squared, so we didn't have to really divide by anything. But if you can, if you notice you have a number in front, if you can, see if you can divide everything to make these numbers a little bit smaller. So all of these happen to be multiples of 4. So I'm just going to divide everything by 4, and including the 0. Because whatever we do to one side, we have to also do to the other side. So what we're actually going to be factoring is x squared plus 3x plus 2. Just to make our lives a little bit easier, we want to try to divide by anything that they may have in common. Okay? So from there, we want to factor. We want things that multiply to 2 that somehow get us to add or subtract to get us 3. Well, the good thing for us is there's only one set of factors for 2, which is 2 and 1. And conveniently, they both will add to 3 if we add both of them together. So x plus 2 and x plus 1 are going to be our factors. We're going to then set each of these parentheses equal to 0. And then we're going to just subtract. So subtract 2 from both sides, so x equals negative 2 is one answer. And subtract 1 from both sides, so x equals negative 1 is the other answer. So again, this is the factoring method. So if the directions on the quiz or test call for factoring, then this is how we would do the factoring method. So let's try one more factoring. Let's say we have 2x squared plus 5x minus 3 equals 0. Right? Now in this case we have a 2 in front, but none of these other numbers are divisible by 2, and actually none of these numbers really have a number that they have in common. So we can't do our trick that we did before. We can't divide by anything, which is fine. So what we'll actually do is we'll have to use what we call the AC method if we have to factor, if the directions say factor. All right, so the AC method would be where we take this number in front, this is considered the A. This last number here is considered the C. So we're going to do 2 times 3, or 2 times negative 3, which is negative 6. So then from there, we want to figure out what are some factors of negative 6 that could add or subtract to get us 5. So we have 6 and 1, and we have 3 and 2. Okay? So we need them to somehow multiply to a negative 3, but they need to add or subtract to a positive 5. And actually, the only one is, because this is actually no longer a negative 3, it was 2 times 3, so we're trying to get them to multiply to a negative 6, but add or subtract to get us to a positive 5. So the only set that would work would be if we do a negative 6, if we do a positive 6 and a negative 1. Okay? So the next step, once we figure out which set are going to work, so again, we did 2 times 3, that gave us 6. We were trying to find factors of negative 6 that would get us to 5. So once we find the pair that will work, we're going to expand the middle part here. Okay, we're going to keep these two guys the same, but we're going to expand this. So the next step would be 2x squared. Well, the positive 5, that came from doing 6x minus 1x. And then we bring down that minus 3. So the 2 came straight down, the negative 3 came straight down. We expanded this positive 5x to be 6x minus 1x, and that came from finding those factors there. Now the next step, we're going to split it down the middle, and we're going to pull out whatever we have in common on each side. So over here, they both have at least a 2 in common. We can pull out a 2, and they have at least one x in common. So we can pull out a 2x. Then what we be left with, if we pull this 2 out and one of the x's out, we're left with 1x for this term. But if we pull a 2 out and an x out, we're dividing those, we're left with a 3. Now remember, when we do this method, you should always be able to multiply each of these to get back to this here. Okay, now we go to this side. Negative x and negative 3, the only thing they have in common is a negative 1. We do that, we're left with an x plus 3. Okay? And so these two parentheses are the same. So that means that our final set of factors is going to be x plus 3. And it's going to be then whatever we had left over. So this 2x and the negative 1 here. So our other set of factors is 2x minus 1. Okay? This is all technically still equal to 0 for all of these steps. Okay? So once we get here, I'm just going to release this up here and rewrite it. Once we get to x plus 3 times 2x plus 1 equals 0, we're going to go into our zero product property. So we are then going to set each of these equal to 0. And then we're going to solve. Or finish solving, because we use factoring to kind of help us get halfway there. And now we need to use algebra to take us to the final answers. So we're going to subtract 3 from both sides. We get x equals negative 3. is one answer. We're going to subtract 1. We get 2x equals negative 1. Don't forget, we got to divide by 2. So x equals negative 1/2 is the other answer. So negative 3 and negative 1/2. All right. So one thing to also keep in mind with these, be careful, and you may know from your notes how your teacher wants you to record your answers. Some teachers are fine with you leaving it as x equals negative 3 or x equals negative 1/2. Other teachers would like you to list it as negative 3 comma 0 and negative 1/2 comma 0. These are what we would call the x-intercept forms. If your teacher wants you to put them as coordinate points, we'd have to list them like this. Other teachers may also want you to list it as the set of values. So they may want you to list it like that. But you can refer back to your notes to see kind of how has your teacher been allowing you to leave the answers, whether like this, whether they want it in coordinate form as points, or whether they're fine with you putting it like in a solution set like this. And in the solution set, we always put the smallest number first and the larger number second. Okay? So that's the factoring method. So just to kind of recap with factoring, we are just taking an equation, a quadratic equation, and we are trying to figure out how we can put it into these sets of parentheses or factor it. And then once we factor it, we're taking those sets of parentheses and setting them equal to 0. So that's the factoring method. If we go on, let's look at the square root method. Alright, so the square root method is usually the most helpful when you have the equation in vertex form. So if you have the equation kind of in this type of format, where it's like a quantity squared plus a number equals 0, this is usually when the square root method is really, really helpful. So as an example, let's say we have x plus 3 squared equals 36. Okay? And in this case, we really don't have it in the same form as standard form. Standard form is like ax squared plus bx plus c. So this is when we would do factoring. If you're given something in standard form, we would usually do factoring. But if we have it in vertex form, square root method may be the most easiest because it's kind of already set up that way for us to do it. So once we do, for square root method, there's one thing we have to remember. The parentheses has to be by itself. So if there are numbers in front or numbers back here, we got to move all those to the other side before we can do anything. But in this case, this parenthesis is already by itself. There's no numbers in front here and no numbers back here, so we can go straight into square rooting it. So we're just going to literally do the square root of both sides. Okay, now the square root and the squared, they actually cancel each other out. So all we're left with over here is x plus 3. And you can write the parentheses, or you don't have to if you don't want to. Over here, the square root of 36 is either positive 6 or negative 6. So for these, we always should have two answers for the part on the left. It's either positive 6 or negative 6. Okay? So from here, we're going to break out into two different equations. X plus 3 equals 6, and x plus 3 equals negative 6. Those are our two options. And then we're going to solve. So I'm just going to subtract 3. We get x equals 3 as one answer. I'm going to subtract 3 here. We get x equals negative 9 as the other answer. So one thing to notice with the square root method, you don't have to have this equal 0. We're not using the zero product property. That was something for factoring. But once we find the number on the right, we just set up one equation equaling the positive version of that number and one equation equaling the negative version of that number. And then we just solve from there. So we get x equals 3 and x equals negative 9. Let's try another one where we actually have to do a little more cleanup before we can do a square root. So let's say we have 3 times x minus 1 squared plus 4 equals 52. Now in this case, we have a number in front and a number back here. We have to move those over to the other side first before we can start doing the square root. We want to do addition and subtraction first. So you're always going to do this number first, get rid of that number first, and then you're always going to get rid of this number second. Right? So the first thing we're going to do to get rid of this number, we're just going to subtract it from both sides. So now we have 3 times x minus 1 squared equals 48. And then we want to get rid of this number So we're going to divide both sides by 3. Okay? We're dividing because this is being multiplied right now. We want to do the opposite. So we're going to divide both sides by 3. So what we're actually left with is x minus 1 squared equals 16. And now we're kind of where we started off with that first example. We have nothing in the front, nothing back here. We can go straight into doing square roots. So I'm going to erase this up here and rewrite it so we have a little more space. So now we're at x minus 1 squared equals 16. Okay, now we can go straight into square rooting both sides. So we do square root, square root. We know that the square root and the squared, this is going to cancel. So we're left with x minus 1 equals, now the square root of 16 is, we would normally say 4, but remember, it's either positive 4 or negative 4. Okay? And the reason why it's going to be positive or negative is because 4 times 4 equals 16, but negative 4 times negative 4 also equals 16. So it could either be positive 4 or it could be negative 4. Okay, so then we're going to break it into our two equations, x minus 1 equals 4, and x minus 1 equals negative 4. Okay? And then we're going to just clean it up a little bit. We're going to add 1 on both sides, so we get x equals 5. That's one answer. And then we're going to add 1 here, so we get x equals negative 3 is the other answer. So negative 3 and 5 are the two answers. Okay, so to kind of recap for square root, if it's in vertex form, if you're given an equation in vertex form, best bet is to probably use square root method. It would be much easier than trying to factor. What we would do is we would, if there are any numbers in front or behind the parentheses, we got to get rid of those first. Then we take the square root of both sides, remembering that the square root of the number is going to be a positive version or a negative version. And then we write our two separate equations. Let's say you were given something that actually doesn't give you a nice perfect square. Let's say that you had x plus 5 squared minus 6 equals 36. Okay, we know we got to get rid of this number. We can't have it here before we do the square root. So we would add 6 to both sides. So we have x plus 5 squared equals 42. Then we do the square root. We know the squared and the square root are going to cancel. We get x plus 5 equals, now the square root of 42, there's no number that we can multiply by itself twice to get to 42. So we're going to have to keep it in this form. So we'll have a positive and a negative. We'll just keep it as the square root of 42. Okay? And from here, we're just going to subtract the 5. Now, we can't combine the 42 and the 5 together because this is stuck under that square root. So we have to keep these separated. So we have, and actually, before we do that, let's do the same method that we did for the other two. We're going to break it out into our two equations. X plus 5 equals the square root of 42, and x plus 5 equals the negative square root of 42. So then from there, we can go ahead and we subtract 5 from both sides, keeping in mind we cannot combine the 5 and the 42. So we get x equals negative 5 plus square root of 42. And we subtract 5 over here. So we get x equals negative 5 minus the square root of 42. Okay. So those would be our two options. They look kind of awkward. They're not as nice and clean as the other ones, but that's fine. So if you're ever given a number that's not a perfect square, you just have to keep it inside of the square root when you do all your math. So your final answer is going to be a number plus that square root and a number minus that square root. Okay. All right. Let's look at the quadratic formula. So we said there were 3 methods that we can use to solve equations. We can use the factoring, which we talked about. We can use square roots. And the last one is the quadratic formula. Okay. Technically, you can use the quadratic formula or any type of equation. This is the third type. But quadratic formulas are the most useful when you have an equation in standard form. So if you have it in standard form and you can't factor it. And of course, if the directions tell you to use quadratic formula, then we have to use quadratic formula. But if you're able to choose which option you want to use, we really only use a quadratic formula if we have to. So if it's in standard form and if we can't actually factor it. If you can factor it, factoring is going to be much quicker than using the quadratic formula. Now, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over, now the division bar goes all the way over to this part here, to a. Okay? All right, and a is the number in front of the x squared, b is the number in front of the x, and c is just the number that does not have a variable. So let's throw up an equation. So let's say we have x squared plus 6x minus 1. So if we have x squared plus 6x minus 1, there is no way that we can find numbers that multiply to 1 that somehow get us to 6. Okay, so it's in standard form. We have x squared, x, and then a constant, but we can't factor it. So we're going to have to use the quadratic formula. All right, so let's identify what our a is and what our b is. So a is 1. That's the number in front of the x squared. This is our b value. And c is negative 1. Okay, so I'm just going to plug them in. So we're going to do the opposite of b. So b was positive. We're going to do negative 6. So instead of positive 6, we're going to do negative 6. We're going to do 6 squared minus 4 times 1 times negative 1, all divided by 2 times 1, 2 times a. All right, now we just have to simplify as much as we can. Now with these, it's not uncommon for you to end up with square roots or things that don't simplify nicely. That's fine. All right, so we end up with negative 6 plus or minus the square root of 6 squared is 36. Negative 4 times 1 is negative 4, times another negative 1 is a positive 4. So this is actually plus 4 in here. All over 2 times 1 is just 2. Okay. All right, and so then that goes to negative 6 plus or minus the square root of 40. 36 plus 4 is 40, all over 2. All right, and then let me scoot this over a bit. I'm going to rewrite it. So our two answer options are negative 6 plus the square root of 40 all over 2. And our other answer option is x equals negative 6 minus the square root of 40 all over 2. Okay? And the plus and minus comes here. So negative 6 plus the square root of 40 over 2, that's one answer. And negative 6 minus the square root of 40 over 2 is the other answer. So these would be our two answers if we're using the quadratic formula. Okay, again, we only use the quadratic formula to solve if we have something in standard form, like we did here, but we can't factor it. All right, so let me show you two other examples. These are a little more on the tricky or difficult side in case your teacher wants to give you ones that are a little trickier to deal with. So let's say you're given the equation x plus 3 squared equals 36. Okay, we know that this is in vertex form, so we usually would want to do square root both sides. But let's say the directions say to factor. So they don't want you to actually use the vertex square root method. They want you to factor. Well, how are we supposed to factor that? Factoring always has to be in standard form. And we said standard form is ax squared plus bx plus c. Well, this right here is in vertex form. It's not in the right form. So we have to get it into standard form. So the way that we actually do that, we're going to have to rewrite this. X plus 3 squared is the same as saying we have x plus 3 times another x plus 3. Okay. Then from there, we're going to have to FOIL. Okay. We need to get rid of these parentheses. So x times x gives us x squared. 3 times x gives us 3x. X times this 3 gives us another 3x. And 3 times 3 gives us 9. So we're just FOILing it out to try to get it into standard form. Now we need to combine like terms. We need to try to clean it up a little bit. So we're trying to combine like terms next. So these guys are similar. We can combine those. So we get x squared plus 6x plus 9 equals 36. And remember, we said we can only factor if it's equal to 0. It's equal to 36. So we need to get this to be a 0. So we're going to subtract 36 from both sides. So we get x squared plus 6x minus 27 equals 0. Now we're in standard form, it's equal to 0. Now we can try to factor it if we can. If we can't factor it, we got to use the quadratic formula. But hopefully this is something that we can factor. So we need the factors of things that multiply to negative 27 but give us positive 6. So factors of 27 are 27 and 1, 9 and 3, and that will be it. And actually, the good thing is 9 and 3 look like they'll work. Okay, we just need to have a positive 9 and a negative 3, so they would add to positive 6. So we're going to get x plus 9, x minus 3, set it equal to 0. Okay, we're going to set up our two equations, x plus 9 equals 0, x minus 3 equals 0. Okay, we're going to subtract 9. We get x equals negative 9. So that's one answer option, x equals negative 9. We're going to add 3 for this one. We get x equals 3 for the other answer option. Okay, so we get negative 9 and we get 3. So to kind of recap, even though our original equation was in vertex form where we would have wanted to do the square root method, we can actually factor as long as we FOIL out this part here, and all we did there was it was x plus 3 squared. We wrote it out twice. We FOILed or distributed, and then we combined in like terms. But then we had to move this 36 over because we can't factor unless this equation is equal to 0. Once we got it equal to 0, we found the factors that multiplied to 27. They got us to 6, which got us here. And then we took each of those and we used the zero product property. So we set each of these parentheses equal to 0, and then we solved. Okay? So it's just a little more work than if we could just do the square root method. We could have just done it in 1 or 2 steps. All right, so let's say, as another example, let's say they give you something in standard form, but they want you to use the square root method. Okay, so let's say they give you x squared minus 4x minus 12. Okay, this is in standard form, but let's say the directions were to use the square root method. Again, we usually only use the square root method if it's in vertex form, where it's like a parenthesis squared, but we don't have that, and this is equal to 0. We would love to just factor this, or use the quadratic formula if we had to, but they want us to use the square root method. So the first thing we actually have to do, we have to get this into vertex form. We got to get this into vertex form, and just to remind ourselves, vertex form is like this. So we need to somehow get it into that form. Right now we have it into standard form. So this is where we're going to have to complete the square. This is something you guys practiced in the last unit. Okay, so the first thing we want to do, so we're trying to convert to vertex form. The first thing we want to do is we want to move the constant, or move the c value. Okay, so that's this guy here. We got to move that over to the other side. So we're going to add 12 to both sides. So now we have x squared minus 4x. I'm going to leave a little bit of a space. We're going to fill that in a second. Equals 12. Okay. And then the second thing, once we move the c value, we're going to add new c value. And we want to add in a new c value. So I'm going to put in a blank here. This is where our new c value will go here. This is where whatever we do on this side, we have to also do on the other side. All right. And so the way we add our new c value is we take the b value, we divide it by 2, and we square it. Okay. So this is the b value here. We're going to do negative 4 divided by 2. So we'll do it in steps. So negative 4 divided by 2 is negative 2. Then we will square it. Negative 2 squared is 4. So that's what we're going to put here, and we're going to put here. Okay. So we just took negative 4, we divided it by 2, and then we got negative 2, and we squared it and put that in there. So now that we've moved the c value, moved that 12 over, we found our new c value by using this equation. The next thing we want to do is we want to factor the left side. So factor, I'll say left side. And really it may not always be the left side, but we're always factoring the side that's in standard form, this guy over here. Okay, so the way that we would factor that, we need things that multiply to 4, they get us a negative 4 here. So multiply to 4, but add to a negative 4. It's going to be x minus 2 and x minus 2. We're going to add these two together to get 16. Okay. Well, x minus 2 times x minus 2, we can actually write that as x minus 2 squared, because they're identical. And voila, now we are actually in vertex form. So once we're in vertex form, we can go straight into the square root method. Okay? And keep in mind, we're not changing the answers. So what the answers that we get when we solve using the square root method are the same answers that we would get if we were to factor. We're just changing the appearance of the equation to make it a little bit easier for us to use the square root method. Okay, so now here, once we're in vertex form, we're going to do the square root. We know the squared and the square root cancel. So we're left with x minus 2 equals, now keep in mind, this is either positive or negative. Square root of 16 is 4. So we got our two equations here. X minus 2 equals 4, and x minus 2 equals negative 4. Okay? And then from there, we're just going to solve. We're going to solve. We're going to add 2 over to both sides. So we get x equals 6 is one option. And add 2 to both sides here. We have x equals negative 2 is the other option. Okay? So 6 and negative 2. So let's see if we actually did get the same thing as if we were to have just factored it. So I'm just going to erase some of this stuff here. So this was the original equation that we had. Okay, so if we were to have factored that, we need things that multiply to negative 12, but somehow get us negative 4. So we have 12 and 1, 6 and 2, 3 and 4. Okay, and so this would be the one that would work. We have to get to a negative 4, so it has to be a negative 6 and a positive 2. So x minus 6, x plus 2. Then we use our zero product property. We set each of those parentheses equal to 0. We're going to add 6, x equals 6. We're going to subtract 2, x equals negative 2. So we actually did with the exact same answer. We got 6 and negative 2 here using just factoring, and 6 and negative 2 using our whole square root method. Okay? So to recap, if you're given something in standard form, but they're asking you to use the square root method, we have to convert to standard form by completing the square. Now, one good thing about this test is you should be able to check your work. So once you find your answers, you should be able to plug it in to make sure they work. So we said x equals 6 and x equals negative 2. We can always check it to make sure it works. So we should be able to plug the value in for x to see if it actually does equal 0. So let's try it. So 6 squared, so instead of x, I'm putting in 6, minus 4 times 6 minus 12 equals 0. We're testing it to see if that actually works. If it equals 0, then we know our answer is right. If it doesn't, we need to redo our work. So 6 squared is 36. 4 times 6 is 24. Okay, so 36 minus 24 is 12. 12 minus 12 actually does equal 0. So it did check out. So at least 6 we know is definitely right. We have to do it for each answer option. So we have to do the same thing using negative 2 now. So instead of x, we're going to put in a negative 2. So negative 2 squared, because it was x squared, so we're going to do negative 2 squared, minus 4 times, instead of x, we're going to do negative 2, minus 12 equals 0. So negative 2 squared is 4. Negative 4 times negative 2 is plus 8. Minus 12 equals 0. We get 4 plus 8 is 12. Okay, and so we also see that 12 minus 12 does equal 0. So that actually worked. So they both actually work. Okay, so again, this is one quick way that no matter what form you have it in, you can always take your answer that you get and put it back into the equation to see if it actually works. So hopefully this video was helpful to review the different methods. So let's just do like a quick summary of when we use each method. All right, if we have something in vertex form, our general go-to is going to be factoring. But we'll use the quadratic formula if we can't factor. So I'll just say use quadratic formula only if you can't factor. But of course, if the directions say to use a quadratic formula, use it even if you can factor. Just always follow what the directions tell you. If you can choose which way you can solve it, only use a quadratic formula if you can't factor. Okay? Let's say you're given something in vertex form, where it looks like this. Okay? And you may even have a number in front like that, whichever. Okay, so if you have it in vertex form, you want to use the square root method. If you can choose how you solve it, you would use the square root method. It would be your best bet. But remember, you have to move extra numbers. Okay, so what do we need? We need this parenthesis to be completely by itself. So this k value would need to be moved to the other side. We need to divide by that a to get rid of it before we can start doing square roots. Okay. So hopefully this was helpful to kind of review all of the different methods you guys have been doing.